Okay, so on the review, on 23, we've so far graphed 3 different functions, yeah? The y is less than or equal to 9. The x plus 2y, we did sketch that one, right? X plus 2y is less than or equal to 16. We subtracted x over. We then divided by 2 and found that my equation was y, or inequality was y is less than or equal to negative 1/2 x plus 8. So we have a positive 8 and a slope of negative 1 over 2. So if you haven't graphed that already, go ahead and do so. And that's less than or equal to, yeah? Okay. So now we need to work on the others. Okay. The next equation that we're going to solve for y, or inequality, is x minus y is less than or equal to 7. X minus y is less than or equal to 7. It is very important that you guys write these down, because if you just think you can write it, or you can draw it without just thinking about it, then you're going to miss things. You want to solve for y, right? How do I solve for y? Subtract x. So I subtract x from both sides. What am I left with over here? A negative y. A lot of people just write down the y, but don't forget that it is a negative y. It's less than or equal to negative x plus 7. Okay? I need to get y by itself. Right now I have a negative y. So what do I do with that negative? Okay? If you divide by negative 1, how many things do I divide by negative 1? Everything. Okay, so I divide by negative 1, divide by negative 1. Now, is there anything that I have to be aware of when I divide by a negative? Exactly. This has to flip when you divide or multiply by a negative on an inequality. Okay? Now, if you don't do that, if you leave it as less than, when you graph it, you'll notice that something is wrong. And we can talk about that in just a second. What's a negative x divided by a negative 1? That's okay. Positive 1x. And then positive 7 divided by negative 1. Okay. So I'm going to now graph y is greater than or equal to x minus 7. What's the y-intercept? Negative 7. So I'm going to go down to negative 7. And what's my slope? 1 over 1. So I'm going to go up 1 over 1. Okay, now if I connect this with a line, you might notice that this is pointing down and this is pointing to the left, so it makes sense that this would be pointing up, yeah? Because we're trying to enclose the region. If you forgot to flip the inequality and you drew your arrows pointing down, then you might notice that something is wrong and try and look for what you should change, okay? But it should definitely point up because we're talking greater than. You're trying to enclose a big area, okay? How many more equations do I have? I just have one, right? Interesting. Okay. So now I need to work with 2x plus 3y is greater than or equal to 9. So I've sketched x minus y is greater than or equal to 7, and x plus 2y, sorry, less than or equal to 7 is less than or equal to 16. And last one. 2x plus 3y is greater than or equal to 9. So first step, okay, minus 2x. So I'm left with 3y is greater than or equal to negative 2x plus 9. What do you want to do now? Divide by 3. So I divide by 3 here, here, and here. Y is greater than or equal to negative 2/3 x plus what? Plus 3. Okay. So we're ready to sketch. I need to graph a y-intercept of what? Positive 3. So y-intercept of positive 3. And what's my slope? Negative 2 over 3. So my y-intercept is positive 3, and my slope is a negative 2 over 3. So I'm going to go down 2 to the right 3. Down 2 to the right 3. Or up 2 to the left 3. 1, 2, 3, up 2, left 1, 2, 3. Now was this greater than or less than? I don't remember. Greater than? So where do the arrows point? Arrows point up. Okay. So can we tell which region we're dealing with? It's got to be greater than this line. But greater than this line, but less than that line, less than this line, and less than that line. Now a problem like this is probably worth on a test about 10 to 11 points. That's quite a few. We've only got so far 1, 2, 3, 4, 5, 6, 7, 8. Well, actually that's quite a few. 1, 2, 3, yeah. Where do the rest of the points come in? It says for the following linear programming problems, optimize, maximize, and minimize the objective function. Do you remember what we do to find the max and the min? Okay, we plug some points into 10x minus 2y, right? What specific points do we plug in? The vertices. And the vertices are any intersection point, right? So what is that one right there? Negative 2, 9? Okay, so one of my vertices is the point negative 2, 9. So I'm going to write it underneath vertices. What is this point right here? Negative 9, 9. So negative 9, 9. What is this point right here? 6, negative 1. Okay, what is this point here? 8, 1. And I've got one more. What's that point right there? 8, 4. So these are all x's and y's that are the intersections of this enclosed region. And I want to maximize and minimize, which means I need to plug these x's and y's into what function? The objective function, 10x minus 2y. Okay? So 10x minus 2y. Okay. So here we go. I've got, for the first one, 10 times negative 2 minus 2 times 9. Yeah? What's 10 times negative 2? So I've got negative 20 minus 18. That's just adding 20 and 18 and making it negative. That is a negative 38. Okay? Now I've got ten times a negative 2. That's, oops, sorry, x. 10 times a what? A negative 9. That's my x value. Minus 2 times my y value, which is 9. What's 10 times a negative 9? Negative 90, and 2 times 9? So negative 90 minus 18 is 90 plus 18. 90 plus 10 is 100, plus 8 is 108, so negative 108. Okay. And now I'm going to work with 6, negative 1. So 10 times what? 10 times what? The x value is 6. Minus 2 times the y value, negative 1. What's 10 times 6? 60. What's a negative 2 times a negative 1? So that's actually plus 2. Yeah? Which means that's 62. Now I've got 10 times 8 minus 2 times 1. So 10 times the x minus 2 times the y. I've got 80 minus 2, which is 78. Now I've got 10 times 8 minus 2 times 4. What's 10 times 8? Minus 8, which is 72. So do I know what the max is? Okay, so I'm going to put max equals 78 at what point? At 8,1. So max equals 78 at 8,1. And min equals what? Negative 108 at negative 9,9. Okay? We good? Okay. Okay, transformations. Do we remember them? Let's try. Okay. So, the first thing it says is domain, and what I'd like you to do is label along the bottom of the x-axis. What is this x value? Negative 5. What is this x value? Negative 3, and this one is negative 2 and 0. Can we also label this y value? Negative what? Negative 3, and what's that y value? 1. Up there. Okay, so why did I label these x and y values? Well, first so I can see domain and range for sure. Okay, so if I want to know domain, domain is how far left and right the function goes. What's the farthest to the left it goes? And what's the farthest to the right it goes? And so there you go. So left and right is negative 5 to 0. Range is from low to high. I have a lot of people that would write 1 to negative 3 right here. Yeah, if you write that, I can't give you full credit. You have to go low number to high number. So negative 3 up to positive 1. Okay? On what interval is the function increasing? Okay, so this first interval, is the function increasing, decreasing, or constant right here to here? It's constant. From here to here, what's it doing? Decreasing. And from here to here? Increasing. So I'm increasing from negative 2 to 0. So you want to know on what interval, not what is it increasing from and to. I'm increasing from negative 3 to negative 1, but I'm increasing on the interval from negative 2 to 0. Okay? What is the maximum value of the function? What's the highest this function goes? And in fact, you don't even have to, you can just use your range. Your highest value is going to be the highest number on that, right? But it is 1. What is the coordinate point of the absolute minimum? Yeah, if you look, this right here, it's not in the middle of the graph, but it's not at the end point, right? The absolute minimum is negative 2, negative 3, that coordinate point. Okay? So we have one transformation problem to go with it, so we might as well go ahead and do that. What does minus 3 on the inside make me do? Okay. Is this kind of important as far as order that we do this? You need to do this one first, which is right 3, opposite on the inside. We're changing the x value. When it says x minus 3, we're changing the x value. What goes next? The number, or that negative, right? A lot of people forget that, or they don't see it. What does a negative make you do? Well, if everything was positive, now it makes it negative, so it flips it over the x-axis. And then this right here is the third thing we do. When you add 2 to a function, you're shifting it up 2. Okay. So I'm going to go ahead and do these transformations. The first thing I'm going to do is I'm going to go right 3. So I went ahead and put the original graph on there so you didn't have to draw it again. So I'm going to go right 3. 1, 2, 3 for that point. This one, 1, 2, 3. Are we okay? John, what you mumbling about? Okay. So if I take this point and go right 3, 1, 2, 3, and connect. And then if I take this point and go right 1, 2, 3, and connect, it should look like the same function, just shifted to the right 3. Yeah? Okay. What's the next thing I do? Flip over the x? Okay. So if this is at positive 1, now it should be at what? Negative 1. Same thing goes with that one, right? This is down 3, which means now it should be what? Up 3. 1, 2, 3. I'm going to go ahead and connect them. And this is down 1, so it should be up 1. Now don't do this. Okay, a lot of people like to try and draw that arc right there. This is arcing out, so this should arc out like that. Okay? It should look like a mirror image of itself. The pink and the green are mirror images of each other. Now what was the last thing? Up 2. So I'm going to take this pink one. Well, that's kind of annoying. Do me a favor. Has anyone already done this problem? Okay. I'm going to go ahead and go up 4. I'm going to change that to a 4 just to get it out of the way. So if you would put plus 4 at the end. I don't want it all up and everything. Okay. So I'm going to take this pink and go up 4. 1, 2, 3, 4. 1, 2, 3, 4. And take this and go up 4. 1, 2, 3, 4. And then take this last point and go up 1, 2, 3, 4. That way it's not all in that other one. Okay? So this is my final answer. Okay? So, what is the value of g of 1? It says g of 1. G of 1 means when x equals 1, what's the y value? When x equals 1, what's the y value? It's 7. Okay? What's g of negative 2? That means I go to negative 2, and I go up, and I guess a 1, 2, 3. So at negative 2, we're at positive 3. So those are my answers. What is the coordinate point of the absolute maximum? What's the absolute highest point? 1, 7. The coordinate point, 1, 7. Over 1 up 7. Okay, let's do 1 of 30 today, and then we'll do the other one on Monday. So, it says, solve the system of equations using a matrix. To get credit, you must write down the matrix you entered into the calculator in addition to the solution. So, we should grab a calculator. Hi, Sarah. Would you just sit right here right now? And then here's this. Okay, so guys, I said you have to write down the matrix that you enter. So first draw this and let's start filling in. What numbers do you enter into the calculator? 1, negative 2, 3, and 18. Yeah? Where are we getting these numbers from? They are the coefficients and the constant, right? So in the first equation, the coefficient of x is 1, the coefficient of y is negative 2, the coefficient of z is 3, and the constant is 18. So are they all in order, x, y, z, x, y, z, x, y, z? Okay, then we don't have to worry about checking order. So what's the next row going to be? 9, 2, -1, and -2. And on the last row, I've got -6, -1, 2, and 4. Okay, guys, I need this matrix written down and then just your answer. So I'm going to take my calculator and where do I go? Do you have a calculator? Okay, so I need to go, you're right, second matrix. Yeah, I don't know why it's being so weird though. Okay, second matrix. So matrix is above x to the -1. Sir, can you grab a calculator? What's that saying? Samantha, do you have a calculator? Let's grab a calculator. Guys, make sure you have a calculator so you can practice doing this. So everyone go to second matrix is above x to the -1. Where do we go? Where do we go? Over to math. And then up or down to RREF, right? Okay. So second matrix, let me go through that one more time. Second matrix above x to the -1. Over to math. Up or down to RREF. Press enter, and now dadgummit. I know it. Thanks. Okay. So, how do I enter in the matrix? Alpha zoom. Is this a 3x4? 3 rows, 4 columns, so I press OK. And then I enter in my numbers, right? 1, -2, 3, 18. 9, 2, -1, -2. -6, -1, 2, and 4. Remember to press the right arrow in between each entry. You press enter after you've got them all down. And hey, do I have the diagonals of 1? Then we're good. If you didn't have diagonals of 1, then you need to check the bottom row. Yeah? All right. What's my answer then? Do I want you to write down that matrix? Nope. I want you to write down the coordinate point. 1, -4, 3. So between this and this matrix, there's your answer. Okay? We will come back and do B on Monday. But let's flip back to the beginning. Okay. So number 2. Determine if the following functions are parallel, perpendicular, or neither. Hey guys, what does it mean to be parallel? The slopes are the same, right? What does it mean to be perpendicular? Your slopes are flipped and the opposite sign, right? Guys, we don't need to be talking too much. And then neither, you don't have either of those relationships. So they either are exactly the same, exactly the opposite, the negative reciprocal, or they're not the same at all. And we're talking slopes, right? What's the slope of this first equation? Okay, so -4/3. Which means I need to solve for the slope on this equation. How do you find the slope? The goal is to solve for what? So let's solve for y. Okay, so I've got 3x plus 4y equals 3. Mickey suggested we subtract 3x, so I'm going to go ahead and do that. Minus 3x. Can I combine 3 and -3x? No, one has an x and one doesn't, so -3x plus 3, or 3 minus 3x, doesn't really matter. And then what's the last step I need to do? If you divide by 4, the number in front of x is the slope, right? The slope is a -3/4. So this one has a slope of -4/3, and this one has a slope of -3/4. Are they the exact same? So they are not Parallel. Are they flipped fractions? But but in order to be perpendicular, one has to be positive, one has to be negative. So they're not perpendicular, which means they are neither or neither. However you want to do that. Okay? Alright, number 4, factoring. What number is in the very front? What's your leading coefficient? What's your leading coefficient? What's the number in front? That's a 1, so do I have to do bottoms up? Nope. I can just find the factors of what? That add up to 3. So remember, if you need to, you can go to y equals and do negative 40 divided by x to look for your factors, right? Go to the table. Okay, 1 and 40, 2 and 20, 4 and 10, 5 and 8. 5 and 8 have a difference of 3, right? Is it 5 minus 8 or 8 minus 5? 8 minus 5, so I've got a negative 5 and a positive 8 that add up to positive 3. So that is an x minus 5 and an x plus 8. Guys, how do you check if you're right or wrong? Well, couldn't you redistribute this out and see if, or distribute it out and see if you get that? Okay. All right, number 6. What's that number in front? Can I factor a 3 out? 17 is not divided by 3, right? Not evenly. So that means I have to do bottoms up. So I multiply 3 times 24, which gives me 72. So I'm looking for the factors of 72 that add up to what? 17. I've got 1 and 72, 2 and 36, 3 and 24, 6 and 12, I agree. 8 and 9, I agree. There might be more, but what is, yeah, because you got 4 and 18. Yeah. But which ones add up to 17? 8 and 9. So I put x plus 8 and x plus 9. But what? I multiplied by 3, yeah? So divide by 3. Does 8 divide by 3? So it's bottoms up. Thank you. 3x plus 8. Does 9 divide by 3? So it's x plus 3. Okay? What am I wanting you to do on number 8? Okay, so what can you do with this expression? Distribute it out? Okay. First, I'm going to distribute the 2x to the 5x and the 2x to the negative 10. You got to distribute each term to the other two terms, right? Hey, what's 2x times 5x? 10x squared. What is 2x times negative 10? Negative 20x. The biggest thing to be careful about is the x's, forgetting them. Now you got to distribute negative 5. Negative 5 times 5x is negative 25x. And then the last thing I got to distribute is the negative 5 to the negative 10, and that is plus 50. Can I combine any terms? That's just adding negatives. So it's 20 plus 25. Okay. They both do. You just forgot an X somewhere. Okay? Everyone go to number 10. I'll give a test bonus point if someone wants to come solve this on the video. the speaker's right there. So just kind of talk. So you can see what you're doing up there, and you can use your pens. Okay. Guys, I'm gonna offer that up to some other people if you want to look through the ones that are left over and see if you want to.
Do you want me to use a ton of different colors like you do?
That's just whatever you want to do. I don't care.
Okay. Okay, so first we need to distribute the 4 to that. We'll also distribute over here too.
Don't forget to distribute that negative.
So you'll get 4 times x is 4x. What's 4 times 5? Oh, okay. That equals. Then the negative times x, negative, makes the 4 negative 4.
Remember
X.
to see the negative to both the x and the 4, right? Okay, so tell us what you're going to do next.
Well, I want to get the x by itself, so hold on, let me see where I'm at. What did I do? I have to see what I'm doing.
Well, you can ask them what to do.
Yeah, what do you do next? So 4x plus 20 equals the 1x.
So she said negative x and plus 2x is positive 1x, right? Okay, and then minus the 4.
Do you subtract the 1x first?
Let's get the x's together. Do I care about the order that you saw that you moved? I don't. I like to go with the variables first, but it's up to you. So 3x plus 20 plus negative 4 because the 1x is canceled out, right?
Okay. Oop, paper.
You just write it again.
I'm just gonna use it.
Here we go.
Yeah, that's so much better. Okay. So 3x plus 20. And y'all wanted to subtract the 20? Then what does negative 4 minus negative 20 get? Or minus 20?
Negative 24.
Okay.
That's it. Divide by 3.
Equals?
Negative 8, sorry. Negative 8.
Yeah.
Good job. Good job, Jake.
I get to sit in the teacher's chair. I
It's
feel like a
true.
big child.
A child nonetheless, but a big one.
Yep.
Okay.
This is purple.
Yeah, there you go. Okay, find the recursive formula in the next 3 terms.
Okie dokie. My hand is huge on this, by the way.
So just be aware of. Alright, let's tilt it a little bit. There we go.
Okie dokie.
And there you go.
Alright, so recursive. This is too low. I'm gonna hit it.
Okay. We'll move it up. That's okay.
It's a red hand. That's for sure.
Okay.
Okay, so you get x of n equals xn minus 1 plus the difference, which is adding 4.
Okay, so let's wait a second. Are you all familiar with the formula?
Yeah.
Okay.
I made that one a little too
Thing
big.
that I would caution you on your formula. That n minus 1 is all in this.
Yeah, well, my bad.
Okay. Alright. And then plus 4. Now where did you get the plus 4? Where did you get the plus 4 from?
It's the difference between the numbers.
Can you draw an arc between that and the plus 4 was?
Yeah. like that. Negative 28. Ta-da. Do I continue? X of 1, man. Yeah. Yeah. It's, yeah. Beautiful writing. Whatever, man. Continue. Three. You're very welcome. I'm glad I could teach. I might pick her up as a professional.
You should.
I don't think I'm.
Okay, never mind.
I'm gonna be a therapist.
Okay. Alright, does anyone work 14 or shall I? Oh, okay, thanks.
This is pretty easy. I volunteer men's as treatment.
If you want to.
I have bad handwriting, so never mind. I can do it.
Do it.
Don't jack up. That's all.
And I will be up there in case, you need help.
I can write really well.
When you hold the pen, don't hold it like, put your hand over a little bit further away. Okay, the first thing is to graph the given function.
That one's broke. I'll use this one.
Okay? So now I'm going to start talking about what we got to do.
So first thing, you gotta take this. You gotta take this equation right here, and you gotta simplify it down. So what you do is you take the dividing sign here, and if you want to make it even more simpler, you can just do that. Yeah, it's kind of. And then you take this here and you divide it, so that would be plus 1. Your y-intercept is 1, which would be right here. And my slope right here would be 1 over 2. So you go up 1 and then over 2. And then you go down. I kind of, when I do this, I like to turn the page so I can make it easier. Yeah.
Okay, so we got part A. Would you please check mark on part A? What is part B?
Part B is you got to find the inverse of the function.
Okay, so we want to find the inverse. Good. Let's give yourself some more space. Okay, guys, which one is easier to use to find the inverse? The original equation or the second equation? What about you? This is pretty easy. This one right here.
Yeah, that's what I did.
Okay, out here, would you write down y equals x plus 2 over 2 over 1?
Y equals what?
So, over here.
Oh.
So that we can answer. So y equals, and then x plus 2y divided by 2. And then tell us what's the first step in solving the inverse.
You got to move the x and the y.
Okay?
You
So
switch.
the x and the y, good.
So it'd be. And
What's the
then
next thing you?
you times this by 2, and then you got to do it on the other side, so it'd be 2x.
Would you go ahead and put the times 2 on that side?
No.
Okay.
Be 2x, and then equals y plus 2.
Okay, so we cancel those 2 sides.
And then you subtract 2 on this side over to the other side, so it'll be 2x minus 2 equals y.
Equals y inverse?
Yep.
So that little. Thank you. Alright, would you scroll that up a little bit? There we go. Is that going cool? Yeah. Okay, so then you would sketch. Your y-intercept is what?
Negative 2.
-2.
And there's the bell.
I'll finish stretching this out. Okay, good job. remember, when you're graphing inverses, they should be reflections across y equals x. Okay, that dotted line right there. Okay.